Welcome to today's Explainer. We're jumping right into a deep dive on a topic that literally surrounds us every single day. We're decoding the science behind an invisible enemy, environmental pollution. And listen, we aren't just going to be skimming the surface here. We're tracking a very real, very dangerous threat that has thoroughly, and I mean completely, infiltrated our world. We hear the word pollution all the time, right? But scientifically speaking, it is so much more than just some scattered trash on the sidewalk or a plume of dark smoke in the distance. It's actually an invisible, shape-shifting enemy that has already infiltrated our air, our water, and yes, even our own bodies. Think of pollution not as a passive byproduct, but as an active invasion. It happens when external substances are dumped into our natural environment, our land, water, and air, in such massive, overwhelming quantities that they completely corrupt the natural balance. This infiltration makes our environment incredibly difficult to survive in, and in the worst cases, it makes it completely unfit for any form of life.
Okay, let's dive into this. Because the fascinating and honestly terrifying thing is that not all of these invaders act the same way. We can basically divide them into two main camps. First up, we have the stubborn invaders. These are known as primary pollutants. Think of everyday things like plastic waste or the pesticide DDT. They are completely unyielding. They enter the environment and stubbornly stay in that exact same chemical form for years, decades even. But then we have the clever ones, the secondary pollutants. Now, these don't just appear out of nowhere. They're actually the result of what I like to call a dark chemical conspiracy. For instance, when primary pollutants like nitrogen oxides and hydrocarbons meet up in the air, they react and mutate into entirely new, highly toxic chemicals. A perfect example of this is PAN, or peroxyacetyl nitrate. Now, among all these atmospheric attackers, carbon monoxide, CFCs, sulfur dioxide, there's one character that is incredibly surprising. It acts entirely like a double agent. I'm talking about ozone. Up high in the stratosphere, ozone is actually our ultimate protector. It acts as this massive, vital shield, wrapping around the Earth and blocking deadly UV radiation from the sun. We literally need it to survive. But when that exact same ozone forms right here at ground level, surrounded by the exhaust of our vehicles and factory smoke, its personality totally flips. It becomes a toxic, man-made pollutant that launches a direct attack on our respiratory systems.
You really can't talk about air pollution without bringing up smog. But have you ever wondered where that word actually came from? Let's take a quick trip back in time. The year was 1905. A physician named Dr. H.A. Desvaux was looking out at the thick, unnatural air, and he simply combined the words smoke and fog to coin the term smog. It was a brilliantly simple word used to perfectly describe a terrifying new reality, a dense, soot-filled, toxic fog that was literally suffocating cities.
So how exactly does this modern, invisible enemy build its army in the sky? Well, the creation of photochemical smog happens in a few distinct stages. First, massive amounts of hydrocarbons and nitrogen oxides are pumped into the air from our car exhausts and heavy industry. Next, they just hang there, waiting. Then comes the cruelest twist of all. The life-giving heat and sunlight from our very own sun hits those chemicals, triggering a massive chain reaction. The result? The creation of dangerous ground-level photochemical smog. It's crazy to think about, but the very sunlight that sustains life on Earth is essentially being weaponized against us by our own emissions.
Now, what's really interesting about this slide is the sheer scale of the source behind a lot of the smoke. Look at this breakdown of electricity capacity in India. A staggering 73% of the total capacity comes directly from thermal power. And when we dig a little deeper into that massive slice of the pie, nearly 90% of it is heavily dependent on burning coal. And look, when you burn fuel on a scale that massive, you are bound to create a colossal byproduct. And that colossal byproduct is something called fly ash. Now, it sounds harmless, right? Like everyday dust. But in reality, it is anything but. Fly ash is a suffocating, incredibly fine powder born from burning coal. Worse than that, it's laced with highly toxic heavy metals, like lead and arsenic. When this powder drifts down onto agricultural fields, it literally chokes the crops and drastically decreases yields. But there is a bit of a silver lining here. To combat this, strict policies now mandate that thermal plants must reuse this fly ash within a 100-kilometer radius. So they're turning this hazardous waste into wealth by mixing it into cement and road construction. With such massive threats floating around in the air, how do we even know if it's safe to step outside? That's exactly where modern science steps in, translating all this incredibly complex data into something you and I can use every single day.
Introduced back in 2015, the Air Quality Index, or AQI, breaks down the danger level into 6 easy-to-understand color-coded categories. These range from good and satisfactory all the way down to very poor and severe. It's basically our daily warning system, telling us exactly how aggressively the invisible enemy is attacking on any given day. So the crucial point here is what exactly goes into calculating those daily safety warnings. Well, the entire system hinges on a very specific number, 12. Back in 2009, the National Ambient Air Quality Standards were strictly updated to track exactly 12 specific, highly hazardous pollutants. This elite batch list includes microscopic attackers like PM10 and PM2.5, alongside deadly gases like sulfur dioxide and heavy metals like lead. This number 12, it represents the absolute baseline of our atmospheric defense monitoring.
Now let's shift gears and see how this builds into an entirely different battleground, the water we rely on for survival. To fix water pollution, we obviously have to know how it gets there in the first place. There are 2 main entry points. First, we have point sources. These are your visible, obvious culprits. Think of a giant factory pipe dumping chemicals directly into a river. They're easy to spot and thankfully a bit easier to regulate. But the real nightmare? Those are the non-point sources. This is the hidden, diffuse enemy. We're talking about agricultural pesticides and fertilizers slowly washing off vast fields during a rainstorm. It's nearly impossible to trace and incredibly difficult to control.
And no matter where this toxic runoff actually starts, it is all heading toward a tragically predictable final destination. Our world's oceans have effectively become the ultimate dumping ground for global waste. City sewage flows endlessly into the seas, power plants suddenly release boiling hot water directly into aquatic ecosystems, instantly killing marine life. And sadly, it's not just the surface water we have to worry about. The waste festering on the ground is slowly, silently seeping downward, poisoning the underground aquifers that hold the very drinking water we all depend on. While chemical runoff is a bit of a slow poison, some water threats are violent and instantaneous. The devastation of an oil spill is just unparalleled. Oil rapidly spreads over massive surface areas in the blink of an eye. It forms this thick, impenetrable layer that completely blocks oxygen from entering the water, effectively suffocating entire marine ecosystems overnight. Plus, it brings the terrifying risk of fire right on the water's surface. And if an oil spill happens on land, it can permanently and irrevocably contaminate vast reserves of groundwater. To truly understand how much damage is being done beneath the surface, scientists use 2 specific tools to test the water. First up is biochemical oxygen demand, or BOD. Here's how it works. When organic waste enters the water, bacteria naturally rush in to decompose it, and they consume the water's oxygen to do so. BOD measures how much oxygen those bacteria are stealing from fish and other marine life. So a high BOD means low oxygen for everything else. But BOD only measures biodegradable waste. For the full picture, scientists use chemical oxygen demand, or COD. COD is much more accurate because it measures the total organic matter in the water, and that includes the incredibly toxic synthetic waste that bacteria just can't break down. And this brilliantly illustrates the ultimate tragic cost of this pollution. When this invisible enemy infiltrates our water, eventually it infiltrates us. These aren't just abstract statistics. They are real-world medical horrors. Look at mercury. In 1952 in Japan, it caused Minamata disease, catastrophically destroying human nervous systems. Cadmium exposure leads to itai-itai, a bone disease so painful its name literally translates to ouch, ouch. High nitrates in water lead to blue baby syndrome in infants. And excess fluoride? That causes skeletal fluorosis, permanently twisting and weakening human bones. Which brings us to the ultimate question we absolutely must ask ourselves as we wrap up this explainer. Look, we have developed incredible modern monitoring tools like the AQI. We have enacted strict, sweeping laws like the 1974 Water Act. But as we've seen today, pollution is a clever, shape-shifting enemy. It hides in the air, it seeps through the ground, and it invades our water. Are our modern laws and tools truly enough to repair this broken balance? Or is this invisible enemy destined to always stay 2 steps ahead of our solutions? That is the question we have to answer before time runs out. Thank you so much for joining me on this deep dive. Catch you next time.